Alright, part 2, and hopefully in the first part of the video you were able to get an understanding of what the chain rule is. If you haven't watched the first part, really recommend that you do, so just search for it on YouTube, give it a watch and you'll understand what we're doing here. We'll do a little bit of a recap for those who have watched the first video, and I will explain everything I do like I normally would, so let's get in to some more fraction and coefficient based chain rule examples. This is going to be a lot of fun. We've got 2 examples to get through, so let's go. Okay, so here we have our f of x equals 6 lots of 5 take x to the power of 3. And we want to find the dy over dx, which is the difference in y relative to the difference over x, which is our derivative. And again, that's just a point on the line that we can take and we can say, well, this function that we're going to work out, the dy over dx, will be able to tell us the slope at that point on the original function. Well, okay, so now that we've got that all set up, let's go through it using our general form up the top here. Hopefully that will help you. Just remember, it's nice and simple. So, we have 3 and 6 as the first 2 things we have to work with. 3 is our n and 6 is our e. So 3 is our exponent and 6 is our coefficient. So we're going to multiply them together because we're going to bring that down to the front. So again, we're finding the dy over the dx here. And 3 times 6 is 18. Then we write whatever's in our brackets just as is, not changing them. So 5 take x. And then we subtract 1 from our exponent. So 3 take 1, 2. And then, after we've done that, we need to find the derivative of just what's in the brackets. And I think you'll find this pretty easy because, well, there is no derivative of a constant. And if we have negative x to the power of 1, well then, it'll be negative 1 times 1, because we're bringing our exponent down to our coefficient and multiplying them together. And there's a 1 there, technically a negative 1. So negative 1 times 1 is just negative 1. So really, our derivative of the g of x, whatever's in our brackets, is just negative 1. Nice and simple, isn't it? Well, it's always good to simplify. And simplifying in this case is very simple. Negative 1 times 18. Negative 18. Negative 18, 5 take x squared. And I could take any x value, plug it into there, and I would work out, I would have the slope for any given point of the x value relative to this original equation. Awesome! Nice and simple. Chain rule is really good. Again, much better than going through first principles and possibly making an algebraic mistake. And if you have to use first principles, at least you can check using this. Okay, last one. Let's go through it. We have 6 over 5x take 4 squared. Find the derivative, the dy over dx. I will need another line to be able to rearrange this using some index laws, and I'll explain what that is in just a moment. Just want to tick off the second one there. Okay, so we have 6, and what we want to do is, it's nice and easy if we can bring that term there in the denominator up into the numerator. So we've just got a chain, one long chain, not divided over a division bar there. So if that's the case, what we do is if we want to take this to the top, we simply have the exact same thing, but it's to the power of negative 2 instead of 2. Essentially exponent, if it's a positive, it becomes negative, and if it's negative, it becomes positive. So we inverse the operation of the exponent. Hope that makes sense. Now let's rearrange it, shall we? So, 6 lots of 5x take 4 to the power of negative 2 is our nice one-line little function for the f of x that we can work with. So, let's find the f prime of x, which is our derivative. So our f prime of x, just switching between notation here, again, f prime of x, dy over dx, same thing, is we take our n term, if you remember, our exponent and multiply it by e, our coefficient. So -2 times 6, -12, right? And then we just take our g of x, the term that's normally in brackets, and we just, put it in there. We don't even need to change it. It's nice and simple. And then we subtract 1 from our exponent. -2 take 1, -3. Awesome. And now we just, in our last bracket here, we multiply this by the derivative of whatever's in the bracket. So let's go through and find the derivative of what's just in the bracket, shall we? Well, derivative of -4, the derivative of any constant is 0. So we don't have to worry about that. It's just our 5x term. And that's technically 5x to the 1. So what are we going to do? Well, we're going to bring that 1 down, and this is based on the power rule. We always bring the exponent down to the coefficient. 1 times 5, 5. And then we subtract 1 off the end. So x to the 0 is just going to be 1, and when we have 1 times 5 from before, that's going to be 5. So our derivative for this is going to be 5, based on the power rule. And then, in our last line, for the very last thing, -12 times by 5, -60. Again, it's really nice to simplify, and we have some numbers there we can use to simplify. So it's -60, lots of 5x take 4, to -3. And again, we can plug x into any x value into there, and we can get the slope at a given point from our original function. Hope this has helped you. I've gone through 3 examples now on the chain rule. If you haven't watched part 1, this should make a decent amount of sense, but I recommend watching part 1 anyway. So thank you very much for listening, and I hope you've enjoyed it. And that's the chain rule, everyone. Nice, simple, straightforward.